Hey everyone, let's look at number 12 here in 10.1. We're going to determine the limit of the following sequence, which is basically the difference of two logarithmic expressions here. To evaluate this limit, I'm going to use the fact that the natural log of a divided by b is just the difference of logarithms. Again, logarithms are exponents, so when we're dividing like bases to different powers, right, we subtract those powers, and that's why this works. So let's take a look at our sequence and what's the limit as n goes to infinity. Well, it is going to be of the form infinity minus infinity, right? So that is indeterminate, right? As n goes to infinity, the natural log of n squared plus 3, right? N squared plus 3 is going to infinity, so the natural log is going to infinity. And n squared minus 1 is going to infinity, so the natural log is going to infinity. So this is indeterminate. Can't be determined. Again, this limit could be 0, could be infinity, minus infinity, or some finite quantity. All right, so what I'm going to do is I'm going to take this property here and rewrite the difference of logarithms, log of a minus log of b, as the log of the quotient, where a is n squared plus 3 and b is n squared minus 1. And then I can take the limit, push it through, because the natural log is continuous on its domain. And for n greater than 1, this expression is always positive and increasing. So we're fine there. And then what's the limit as n goes to infinity of this? Well, we've talked about this quite a different number of times. I've showed 3 ways that you can show that the limit is 1. You can use L'Hopital's rule, show that the limit is 1. You could look at the highest degree term in the numerator and denominator, look at that ratio, see that that limit's 1. Or you can divide numerator and denominator by the highest degree term, which is n squared. And both of these fractions here then are going to 0, and the limit again is 1. And so all 3 of these ways are valid to show that this limit is 1. And if this limit is 1, then what are we approaching? The natural log of 1, which is 0. So the limit of our sequence is 0, and the sequence converges. Okay, hope this is helpful.